ahead. So, நமக்கு எல்லாருக்குமே we have got another chance to set things right. So, let's make each moment of this year worthy. Okay, so with that note, we'll begin our class. So, just getting things ready. Just give me 1 minute, 1 to 2 minutes. I'm just sharing the screen.
Wow,
Okay,
Manish,
sure.
such a nice ஒரு நியூ இயர் விஷஸ் ஃப்ரம் யூ. கரெக்டாக அதான் அந்த இளைஞர்களுக்கு நான் எப்பவுமே ஹூ இஸ் த பெஸ்ட் டீச்சர் அப்படின்னு கேட்டால், இப்போ சந்தானாவுக்கு யார் பெஸ்ட் டீச்சர்னா, அவர் இப்போ 11th படிக்கிறான்னா 12th படிக்கிற பையன் தான் பெஸ்ட் டீச்சர்.
Correct.
அதுதான் மனிஷ் இஸ் ப்ரூவிங் எவ்ரி நவ் அண்ட் தென். நான் சொல்லுவேன், நிறைய இடத்துல சொல்லிட்டேன், நாங்கள் 8 டீச்சருக்குலாம் அந்த பெஸ்ட் டீச்சர் எங்களில் இருக்கிறதுலையே அது யங்கஸ்ட் தான், ஒரு பையன் ஃப்ரம் பாம்பே அப்படின்னு சொல்லுவேன். ஸோ அவங்க
That's a compliment.
பையன் ஃப்ரம் பாம்பேன்னா அவன் வேறு மாதிரி நினச்சிக்குவான். நான் சொன்னேன், அவர் நம்ம ஊர் பையன் தான், பட் இஸ் தி ஏஜ் அஃப்கோர்ஸ் இஸ் கேலிபர் இஸ் இன்ட்ரெஸ்ட் ஆல்சோ மேட்டர்ஸ், பட் ஏஜ் இஸ் ஆல்சோ ஒரு இட் கிவ்ஸ் இம் எ ஹெல்பிங் ஹேண்ட் அப்படின்னு சொல்லுவேன். ஸோ அது மனிஷ் கேஸில் நான் ரொம்ப நாளாக அந்த பையனை பார்த்ததுனால எனக்கு தெரியுது. ரொம்ப இப்போ என்ன தான் நான் தலைகீழ நின்னாலும் மனிஷ் மாதிரி என்னால் ஆக முடியுமா? ஆக முடியாது. ஐ மீன் சொல்லிக் கொடுக்குறதுல சொல்கிறேன். ஸோ தட் இஸ் வாட் எக்ஸாக்ட்லி தட் இட் கிவ்ஸ் ஒரு அட்வான்டேஜ். ஓகே மனிஷ், தேங்க்யூ. கோ ஹெட் வித் யுவர் கிளாஸ்.
Yes, uncle. Okay. Yes, uncle. Okay, so last class we have done numericals based on the electrostatics part. Electric field and charges we looked at all different aspects. So last class today we are going to look at continuation of certain questions. Adukapram we'll move on to the next part. Second part of electrostatics is what we are going to see, about the electrostatic potential and capacitance. So that is what I have planned for today. So quickly let's move on. Yeah, here comes a question. So we'll move from simple to complex questions eventually. So today, again, starting off the first. Putting the heading for today, so electrostatics. So we are looking at part 2 of our lecture. So here comes the question. Yeah. 3 charges are placed at the vertices of an equilateral triangle of side A as shown in the figure. The force experienced by the charge placed at vertex A in the direction normal to BC. In the direction normal to BC. Normal abdina, it's perpendicular. So normal to BC is, so I'll give you the figure so that you can start working on it. So the vertices I'm marking the sides. Approach charges. Vertex A you have a plus Q charge. Vertex B minus Q. Vertex C you have plus Q. So this is the diagram. Okay, I'll give you the options. So option A, Q square upon 4 pi epsilon naught A square. Option B, negative Q square times 4 pi epsilon naught A square. Option C, 0. And option D, Q square upon 2 pi epsilon naught A square. Yeah. So this is a question. So மூணு charges வச்சு place பண்ணிருக்காங்க. நீங்க you can see in the equilateral triangle. So equilateral triangle அப்படிங்கிறதுனால obviously நமக்கு தெரியும் all the sides are equal. So அது வந்து A, they are using a alphabet small a to represent that. அதே மாதிரி the force experienced by charge placed at vertex A in the direction normal to BC. Normal to BC na you draw a line joining BC such that it is perpendicular to BC. So what is the force experienced? The electrostatic force. This is the question. So diagram நீங்களும் draw பண்ணிட்டு நீங்க try பண்ணுங்க. Just try to mark the direction of electrostatic force from A towards the direction BC normally. So anybody is getting the answer, you can tell. I'll just give you a minute to try it. Yes, force diagrams draw பண்ணிட்டீங்களா? So how is the force diagrams?
Sir, option 0. Option C, sir.
Option C, you're getting 0. Okay. So இங்க பாத்தீங்கன்னா with respect to point A. Point A ல வந்து நமக்கு plus Q charge இருக்கு. So it is interacting with two charges இல்லையா? With respect to charge minus Q and plus Q placed at B and C. So your answer 0 is correct. That's perfectly correct. So explain பண்ண முடியுமா? Can you just try explaining it?
Yes, sir.
Yes.
சார் ஏ வந்து ரிசால்வ் பண்ணணும் சார்.
கரெக்ட். ஆமா.
அப்போ வந்து மேல போறது ஏ வெக்டார், கீழே இந்த ஃபோர்ஸ் வந்து கீழே இந்த பி சைடுல போறது வந்து F1 வெக்டார் சார். F1 இந்த ஏல இருந்து பிக்கு போற ஃபோர்ஸும் ஏல இருந்து சிக்கு போற ஃபோர்ஸும் ஈக்குவலா இருக்கும் சார். ஏன்னா ரெண்டு சைடுல உள்ள ஏரியாவும் ஈக்குவல் சார்.
ஓகே.
அதனால இது ரெண்டு ஃபோர்ஸ் ஈக்குவல் சார். அப்போ நெட் ஃபோர்ஸ் வந்து சார் ரிசல்டன்ட் ஃபோர்ஸ் வந்து ரூட் ஆஃப் F1 ஸ்கொயர் பிளஸ் F1 ஸ்கொயர் பிளஸ் 2F1 காஸ் 120 டிகிரி வரும் சார். ஏன்னா தீட்டா வந்து இங்க 120 டிகிரி சார். 180 மைனஸ் 60 சார். நான் ஈக்குவேட்டர் ட்ரையாங்கிள் வந்து 60 டிகிரினால 180 மைனஸ் 60 120 டிகிரி சார் தீட்டா.
ஆமா, கரெக்ட் கரெக்ட்.
எஸ் சார். அப்போ F is equal to F1 வந்துருது சார். நெட் ஃபோர்ஸ் is equal to F1 வருது சார்.
ஓகே. ஆமா. So you're getting the F1. So இந்த ஃபோர்ஸ் வந்து எப்படி ஆக்ட் ஆகுது with respect to BC? நார்மல் ஆக்ட் ஆகுதா இல்ல parallel இருக்கா?
Parallel சார்.
Exactly. Parallel இருக்கிறதுனால
0
what
sir.
can you conclude? Yeah, you can say that it is 0. ஏன்னா the angle it's you don't have any angle of inclination. சரி. So that is the reason. So இங்க பாத்தீங்கன்னா you have a equilateral triangle. இப்போ at point A தான் நாம வந்து investigate பண்றோம். So when you draw it, each and every vertex வந்து you have the charges. So at vertex A வந்து we had plus q charge, at vertex B minus q charge இருந்துச்சு, and at vertex C you had plus q charge. இல்லையா? So at A வந்து when you are trying to study what is the electrostatic force அப்படின்னு நீங்க ஸ்டடி பண்ணும்போது the force of interaction, A ல வந்து already you had a charge which was positive. நமக்கு எல்லாருக்குமே தெரியும் like charges are going to repel each other. So the direction of force experienced by charge at A with respect to charge at C, both the charges are positive. அதனால the force is going to act in the opposite direction from the line of action AC. So on the force தான் நம்ம வந்து we can represent as FCA because it is directed from C towards A. So it is away. So you can express it like this. Same way, the force of interaction, the force is going to be an attractive force with respect to point B because point B you have a negative charge. Opposite charges attract each other and hence this will be FAB. Okay, so this is the main idea. And both the sides, obviously the sides are same. ஏன்னா இது வந்து ஒரு equilateral triangle அப்படிங்கிறதுனால. And the angle between நம்ம வந்து இப்போ FAC, that is FCA and FAB ஓட resultant கண்டுபிடிக்கணும். So you can use the parallelogram law. So parallelogram rule இல்ல parallelogram law வந்து நீங்க யூஸ் பண்ணி you can find out what is the resultant. இந்த resultant force தான் நம்ம கண்டுபிடிக்கணும். So to find out this resultant, உங்களுக்கு வந்து you should know what is the angle between both the forces. In the full angle வந்து you have to find out. So to find out that complete angle, obviously நம்ம வந்து maths யூஸ் பண்றோம். So இந்த உள்ள இருக்கக்கூடிய angle வந்து 60 அப்படிங்கிறதுனால this angle is going to be 180 minus 60. ஏன்னா it is a complete linear pair அப்படிங்கிறதுனால you are subtracting 60 to get the other angle. So which is giving you 120 degrees. Okay, 180 minus 60 gives 120 degrees. So you found the angle as 120. So rendu force vectors may are separated by an angle of 120. So number resultant force vector வந்து we try to find out what is the resultant. So resultant வந்து you apply the parallelogram law. F is equal to under root of, so one வந்து F1, இன்னொன்று வந்து you can take it as F2, but both are same. So அதனால F ன்னு எடுத்துக்கலாம் generally. ஏன்னா both the forces are of same magnitude. ஏன்னா you have the same type of charges that are interacting அப்படிங்கிறதுனால. So FCA is equal to FAB is equal to some F அப்படின்னு எடுத்துக்கலாம். So we can write it as F square plus F square plus 2 times F into F is again 2F square into cos of 120 degrees. So how much is cos 120 degrees? Maths apply
minus 1 by 2, sir.
Yeah, you get negative 1 by 2. So negative 1 by 2 varadhanala. So here you will get 2F square plus 2F square times minus 1 by 2. 2 would get cancelled off and you get 2F square minus F square, which is F square. So root of F square வெளியில வந்துச்சுன்னா you just get it as F. So இந்த force தான் parallel act ஆகுது. நீங்க பார்க்கலாம் இந்த resultant force வந்து இப்போ வேல்யூ கண்டுபிடிச்சிட்டோம், which is nothing but F itself. But you can see it is acting parallel to BC. So base of the triangle கூட it is parallel. It is present parallelly. அப்படிங்கிறதுனால so the component which is normal to BC is going to be 0. So that's the reason the answer is going to be 0 in this case. Okay, so the answer is 0. Fine. So that's how you solve this question. Moving to the next question. So the next question for the day, the second question. Okay. There is an electric field in the x direction. There is an electric field in the x direction. If the work done in moving a charge if the work is done in moving a charge of 0.2 coulombs through a distance of through a distance of 2 meters along a line making an angle of along a line making an angle of 60 degrees with x-axis with the x-axis is 4 joules, full stop, or let's put a comma. Then the electric field associated is, so I'm giving you the options. Option A, 4 newtons per coulomb. Option B, √3 newtons per coulomb. Option C, 5 newtons per coulomb. And option D, 20 newtons per coulomb. So இதை ட்ரை பண்ணுங்க. ஸோ ஃபர்ஸ்ட் என்ன டேட்டா கொடுத்துருக்காங்க அப்படிங்கிறது யூ கெட் ஃபெமிலியரைஸ் வித் இட் அண்ட் தென் யூ கேன் ட்ரை. அதுக்கப்புறம் நீங்கள் ட்ரை பண்ணலாம். ஸோ எந்த டேட்டா கொடுத்துருக்காங்க ஃபர்ஸ்ட் டேட்டா எழுதிக்கோங்க. ஸோ யூ கேன் சி தட் தே ஹவ் கிவன் யூ த டிஸ்டன்ஸ். அப்புறம் ஆங்கிள் கொடுத்துருக்காங்க. தே ஹவ் கிவன் யூ ஒர்க் டன். சார்ஜ் இஸ் ஆல்சோ தேர். ஸோ என்ன ஃபர்ஸ்ட் ஸோ எந்த ஃபார்முலா யூஸ் பண்ணலாம்?
W is equal to F dot D, sir. F is equal to E into Q into E, sir.
Yes, F is equal to Q into E. That's correct.
So, Q E D cos theta.
Yes, Q E D cos theta. So நீங்க அதை யூஸ் பண்ணி you can find out. Correct. So இந்த கொஸ்டினுக்கு வந்து first given data வந்து data interpretation எல்லா questions-க்குமே. So first data interpretation is important. So I'll underline all the datas. So once you have underlined, அதுக்கப்புறம் you can go with solving. So charge is there. Q வந்து 0.2 coulombs. அதே மாதிரி they have given you the distance. என்னன்னா displacement கூட நீங்க consider பண்ணிக்கலாம், which is 2 meters. And angle theta is also given as 60 degrees. அப்புறம் work done is also given as 4 joules. So இதெல்லாமே கரெக்ட் பண்ணி நீங்கள் ஃபார்முலாவை யோசிக்கணும். ஸோ விச் ஃபார்முலா வில் பி மோர் ஆப்ட் டு யூஸ் அப்படின்னு ஸோ யூ ஹவ் டு திங்க். ஸோ ஒர்க் டன் ரிலேஷன்ஷிப் ஃபர்ஸ்ட் நம்ம யூஸ் பண்ணலாம். ஒர்க் டன் ஆல்ரெடி நம்ம பார்த்தது தான் 11th. ஸோ ஒர்க் டன் இஸ் ஈக்குவல் டு த ஃபார்முலா.
Sir, 20 Newton per coulomb.
20 newtons per coulomb. That's correct. So yeah. So work done formula சொல்றீங்களா? What is the formula for work done? Force.
F dot D, sir.
Yes. It is a dot product of force and displacement. So இந்த ரெண்டு வெக்டரோட dot product தான் work done. So நம்ம dot product expand பண்ணோம்னா you will get F into S into cos theta. So dot product oda resolution தான் இது. So work done is equal to Fs cos theta. And now you go and apply the formula for force. In electrostatics, force is equal to Q into E. நம்ம அதை கொண்டு போய் நம்ம அங்கே சப்ஸ்டியூட் பண்ணுறோம். சப்ஸ்டியூட் பண்ணோம் அப்படின்னா what do you get when you substitute the value for force? The work done formula is going to change. It will change as in terms of electric field. So பார்த்தீங்க அப்படின்னா you will get work done is equal to Q E S into cos theta. That's all. So இங்க வந்து நமக்கு we wanted what is the electric field. Rearrange பண்ணிக்கோங்க. So electric field is equal to work done upon QS times cos theta. Then go for a substitution. Work done is there as 4 joules divided by charge on the 0.2 can be written as 2 upon 10 and the 10 வந்து மேல கொண்டு போய்க்கலாம். And S one is 2 meters into cos of 60 degrees. What is the value of cos 60?
1/2, sir.
1/2,
1/2.
sir.
Correct. 1/2 அந்த 2 மேல வந்துரும். So 4 into 2 into 10 upon 2 into 2. So everything you cancel off. 2 ones are 2, 2 twos are you can cancel off. 2 and 2, 2 fives are 10 and 4 fives are, answer is 20 newtons per coulomb. சரிங்களா? So this is the method to solve this question. So we got the answer as 20 newtons per coulomb and hence option D is correct. Okay, this is the method to solve this question. I hope this is understandable. Okay, yeah, we'll move on to the next
Yes,
one.
sir.
Okay. So third question. A hollow insulated conducting sphere is given a positive charge of 10 microcoulomb. What will be the electric field at the center of the sphere if its radius is 2 meters. If its radius is 2 meters. Options. Option A, 0. Option B, 5 microcoulombs per meter square. Option C, 20 microcoulombs per meter square. And option D, 32 microcoulombs per meter square. So இது try பண்ணுங்க.
Answer 0, sir.
Sir, 0.
Okay, why is it 0?
So inside
Sir,
the
சென்டர்ல வந்து சார்ஜஸ் இருக்காது சார்.
0, sir.
Centerல வந்து you don't have, come again.
சார்ஜஸ் இருக்காது சார்.
Yes,
The
correct.
uniformly distributed.
ஆமா, uniform distributed sphere தான் நம்ம பார்க்கிறோம். So it is going to cancel off and electric field is going to be 0 at all the points inside the charged hollow charged sphere. So that is the reason the answer is 0. So here you need not calculate. Obviously எப்பவுமே center அப்படின்னு சொன்னாங்கன்னா symmetric objects நீங்க பாத்தீங்கனாலே according to the Gauss's theorem properties it is going to be 0. Yes. Okay. Okay. Another model. So here comes the next question. A deuteron அப்படின்னா it is basically a isotope of hydrogen. Hydrogen வந்து 3 isotopes இருக்கு. Protium, deuterium and tritium அப்படின்னு சொல்லுவோம். So அந்த மாதிரி we name this as deuteron. So a deuteron and alpha particle in air are separated by 1 angstroms. Full stop. Continuing. The magnitude of electric field intensity on alpha particle on alpha particle due to deuteron is options. Option A 5.76 into 10 to the power 11 newtons per coulomb. Option B 1.44 into 10 to the power 11 newtons per coulomb. Option C 2.828 into 10 to the power 11 newtons per coulomb. And option D 0. Okay, so you have two different particles. So magnitude of electric field on alpha particle due to the deuteron is what they're asking. So what is the charge on the deuteron? So it's basically the
Positive charge, sir. One positive charge.
yeah, it is a positive charge. It's a positive charge of an electron only. So electron positive charge எடுத்துக்கிட்டீங்கன்னா it is 1.6 times 10 raised to minus 19 coulombs. அதுதான் யூஸ் பண்ணுவோம்.
Yes, sir.
ஆமா. So what is the formula for electric field intensity or just the electric field? E is equal to
E is equal to 1 by 4 pi epsilon naught into Q divided by R square.
yeah kq by r square னு சொல்லிரலாம். Okay, so it is kq by r square.
Yes.
What is r? R is the distance of separation. கொடுத்திருக்காங்க 1 angstrom வந்து நீங்க
sir.
கன்வர்ட் பண்ணனும் ஸ்டாண்டர்ட் யூனிட்ஸ்ல. SI unitsல what is the value?
10 power minus 10,
10
sir.
power minus 10 meters, sir.
Yes, 1 angstrom is equal to 10 power minus 10 meters. கேக்கு வந்து நீங்க எப்பவுமே 1 by 4 pi epsilon naught போட்டு அதுக்கப்புறம் epsilon naught வந்து 8.85 யூஸ் பண்ண தேவையில்லை. K value can be directly interpreted
9
as
into 10
9
power
into
9,
10
sir.
very good. டைரக்டா அது யூஸ் பண்ணிருங்க.
Sir, option B.
Option
B, sir.
D 0 வா?
No, sir. 1.44 in 10 power 4 Newton per 11 Newton per
Okay.
coulomb, sir.
Okay, B for Bombay. Okay,
Yes, sir.
fine. So K is 9 into 10 power 9 times 1.6 times 10 power minus 19 the whole divided by R square. So R square வந்து 10 power minus 10 the whole square. இல்லையா? This is how you get. Okay, so இது simplify பண்ணுங்க. So what will happen? How do you do the further simplification? So 9 into 16 அப்படின்னா எழுதிக்கலாம் into 10 to the power minus 19 plus 9 becomes minus 10 and the 1.6 ஓட 10 கூட நம்ம கன்சிடர் பண்ணணும் which is 10 power minus 1
Minus
இல்லையா? So you can simply say it is minus 20 plus 9 அப்படின்னு எடுத்துக்கலாம். So minus 20 plus 9 would be
minus 11.
yeah minus 11. So minus 11 அதுக்கப்புறம் you bring that minus 20 from the denominator to the numerator becomes 10 to the power plus 20. So minus 11 plus 20. How much is that?
144, sir.
So minus 11 plus 134, you get 9, no?
Yes, sir. Yes, sir.
Yeah, it is 9.
144 into 10 power 9, sir.
Correct. 10 power 9. 9 into 16 is 144. இப்போ நம்ம இது வந்து சிக்னிஃபிகன்ட் ஃபிகர்ஸ்ல எழுதணும் அப்படிங்கிறதுனால 1.44 அப்படின்னு நம்ம எக்ஸ்பிரஸ் பண்றோம். ஸோ 1.44னா ஆப்வியஸா டெசிமல் பிளேஸ் வந்து ஃப்ரம் ஹியர் டு ஹியர் யூஆர் மூவிங். As you move the decimal place towards the left, so the power of 10 increases or decreases?
Increases, sir.
Yeah, it will increase.
Increases, sir.
By 2 place values, it will increase.
10 power
அதனால
11.
10 power 11. So இது வந்து is very important. So the answer is 1.44 times 10 power 11 newtons per coulomb. So hence option B is correct. சரிங்களா? So this is the method to solve this question. That's it. So now we'll move on to the next part. So electric field and charges we have looked at all the aspects. So now we are moving on to electrostatic potential and capacitance. So under aspect we are going to the next part now. So I'll just write down. So we are looking at now electrostatic questions pertaining to electrostatic potential and capacitance. So அதுதான் நம்ம பார்க்க போறோம். So here's the first question. We'll start off with the easier ones and then eventually move on to the hard ones. So inga we'll have a quick recap of the formulas. Okay, and then we will go on to all the problems. We'll have a recap of formulas here. So in the formulas, what are all the possibilities we will see first. So we'll look at the formulas and then we'll eventually move on. Yeah, first and foremost is the potential difference. So இது நம்ம உங்களுக்கு தெரிஞ்சதுதான். So potential difference, how can you express potential difference is what we are going to see. So the first aspect, so we can express potential difference as the ratio of work done in moving a charge from one point to another against electric field. So then you say that there is an electric potential or a potential difference that is being set up. So potential difference is the ratio of work done divided by charge. Okay, so we can express like this. So simply you can say VAB can be expressed as VB minus VA. So potential difference between 2 points of interest A and B. You wish to move charge from point A to point B, where point B is at a higher potential and point A is at a lower potential. So obviously potential difference higher minus lower than we consider பண்ணுவோம். So VB minus VA, which is equal to work done upon charge Q. So நம்ம units ஓட relationship பார்த்தோம் அப்படின்னா, you can simply say 1 volt is equal to 1 joule upon 1 coulomb. So this is the relation between the units. Adhe mari we'll go to the next formula. Then we have the electric potential due to a point charge. So what is the electric potential due to a point charge? So we can say when a point charge Q is placed at a distance of r from it, then you say the electric potential at that point is expressed as V is equal to same thing, K times Q upon
R square.
K times Q by R da. So R square would not come here.
Okay, sir.
Okay, it's KQ by R because the electric potential is inversely proportional to the distance of separation. So one quantity increases, the other quantity is going to decrease. So that is a trend. So that is what we observe here. So it's KQ upon R. So what is the relationship? Again, V is in volts, K you know the value, Q is going to be in coulombs and R would be in meters. Okay, that's it. So this is the second formula. Third one, the electric potential due to dipole we are going to see. What is meant by a dipole?
Charge into distance, sir.
Okay. Dipole abdina, you're having two different polarities. ரெண்டு polarities இருக்கும், ரெண்டு சார்ஜ் இருக்கும். சார்ஜோட மேக்னிடியூட் வந்து சேம் தான், பட் the polarities are going to be different. One would be positive and the other would be negative. That is interacting. So you call that as a dipole because there are di means two. கெமிஸ்ட்ரியில நீங்க படிச்சிருப்பீங்க, டை, ட்ரை, டெட்ரா அந்த மாதிரி போகும். ஸோ சேம் அதே ப்ரிஃபிக்ஸ் தான். ஸோ ஹியர் டை மீன்ஸ் டூ polarities are there. Two charges, system of two charges with different polarities. Okay, so electric potential due to a dipole நம்ம வந்து எக்ஸ்பிரஸ் பண்ணும்போது, so we express this as V is equal to, so electric potential ஓட symbol V தான், it is equal to K times, so இங்க வந்து we are expressing in the vector form. So it's a dot product of the vector P. So what is vector P? Vector P is nothing but
momentum.
Dipole moment, sir.
No, it is dipole moment, momentum illa. So inga vande it is dipole moment times the position vector, which is r bar upon r cube. So r cube is nothing but again the distance of separation between those two poles. So we are expressing like this. So idu vande neenga simplify panninga appadina dot product vande obviously you know it is going to be cos theta. So PR cos theta, the r and r cube vande you will get cancelled off. So K times P into R into cos theta upon R cube. So you can cancel off one R and one R. So finally you get AP cos theta upon R square vandarum. So this is what you get. In the general form, vector formula we எழுதுவோம், and in general form we write it like this. So there are two different ways of expressing, both are one and the same. Okay, so that is the expression. So K vande is the same value 1 by 4 pi epsilon naught. So that is again the same thing. So this is electric potential due to a dipole is what we are seeing in general. But there are two different aspects in dipole. One vande axial line, இன்னொன்னு வந்து equatorial line அப்படினு சொல்லுவோம். So axial line பாத்தீங்கன்னா in the same axis joining the dipoles வந்து we will study. So that is called the axial line. So we will look at both the aspects. So first aspect is a point on the axial line of dipole. Okay, so a point on the axial line of the dipole, what would be the theta? So theta would typically going to be
0.
Yes, it will be 0 or either you can say 180 degrees if it is going to be away. So in the rendu possibilities da. So therefore it can either be plus or minus. So we say the electric potential V axial is equal to either plus or minus K times P upon R square. So you go and substitute cos 0 and what do you get? If you put theta is equal to 0.
1, sir.
Correct. So 1, that's a possibility. And cos 180 is
Minus 1, sir.
yes. So you're understanding why did I put plus or minus? And the rendu angles நம்ம consider பண்ணி தான். So theta, where theta can be 0 or 180 degrees. So in the ஒரு conditionக்கு வந்து you are getting this formula. So we will apply this. அதே மாதிரி the other one is for equatorial line. So equatorial line அப்படிங்கும்போது you will take a point which is normal to your dipole. So normal na obviously perpendicular da. So perpendicular na what would be theta? Theta is going to be 90 degrees. So 90 na உங்களுக்கு அந்த formula எப்படி change ஆகும்?
0, cos 0. Totally 0, sir.
Yes, so it becomes 0. So V equatorial point would be 0. So a point on the equatorial line of dipole. So where this time theta is 90 degrees and cos 90 is 0, and hence we directly say V equatorial as 0. The electric potential at that point is totally 0. Simple. So these are the two aspects. Okay, next. So and then we are looking at the third one. Fourth we are going. The formulas we are seeing. So formula count one is 4 now. The electric potential due to the group of n charges. So இங்க வந்து சூப்பர் பொசிஷன் அப்படிங்கிற ஒரு பிரின்சிபலை வந்து நம்ம யூஸ் பண்ணுவோம். ஸோ எலக்ட்ரிக் பொட்டென்ஷியல் due to a system of n charges or n point charges. So n number of charges when you consider what would be the electric potential due to all those charges. Okay, so n point charges you will take from with respect to a point. Okay, so if you say R1, R2, R3, so on up to Rn are the distances of the n point charges. The n point charges Q1, Q2, say Q3, so on up to Qn. நம்ம generalize பண்றோம். Qn, okay, from a point of observation. So then what happens? So electric potential due to the system of charges. So V oda formula நமக்கு ஏற்கனவே தெரிஞ்சதுதான். V is equal to KQ by R. Yeah. So K times Q upon R. That is a relationship. So இங்க you are having system of charges. So அப்போ நம்ம என்ன பண்ணுவோம்? We have to apply the summation
of I is equal to 1 to N QI divided by RI.
Yes, K வந்து நம்ம summation இருந்து வெளியில எடுத்துக்கலாம். ஏன்னா அது common out அப்படிங்கிறதுனால. So it is sigma I is equal to 1 to N. So now you can take and write it as QI upon RI. So இது பண்ணீங்க அப்படின்னா you are considering all the system of all the N charges. Simple. So this is how you express the electric potential due to a system of N charges. Done. So this is the fourth one. So next one we are going to, so we are done with electric potentials. So இப்போ வந்து நம்ம potential energy பார்க்கலாம். The electrical potential energy. So electrical potential energy. So electrical potential energy of a system of point charges. Pathina, it is basically the work done in bringing the charges to their location from infinity to a point against electric field. You call that as the electric potential energy. So in simple terms, potential energy of a charge, நம்ம எப்படி express பண்ணலாம்? You can express this as the charge multiplied by the electric potential at that point. Charge multiplied by the electric potential at the given point. We can express it like this. So further, you can see what is the unit. Now sometimes questions la vande, I mean generally potential energy nale joules da, there is no doubt, but sometimes they will give you in electron volts. So electron volt la கொடுத்தாங்க அப்படினா நம்ம வந்து we have to change it to joules. So conversion வந்து நமக்கு தெரிஞ்சிருக்கணும். Any idea about the conversion from electron volt to joules?
So into 10 power minus 19.
But what into?
1.6 into.
Correct. 1 electron volt abdina, it is nothing but the charge of the electron only. So the charge of the electron is basically 1.6 into 10 power minus 19. So directly it gets converted to joules. So 1 electron volt is equal to the charge of the electron magnitude. So that is 1.6 times 10 raised to minus 19. So in the conversion you will have to know. So if they give you the electron volts, you have to appropriately convert like this in terms of joules. Joules is the standard unit of energy. Okay, சம்டைம்ஸ் கேலரிஸ்ல கொடுத்தாங்க அப்படின்னா you have to convert from calories to joules. So அது கூட that is also another possibility. So how much is 1 calorie in terms of joules?
4 point.
சொல்லுங்க கரெக்ட். Yes, you are right. Tell me. 1 calorie is equal to it is 4.2 joules. Yeah. So 1 calorie is 4.2 joules. That also you must keep in mind. So in terms, if they have given in terms of calories, what will you do? You need to multiply with 4.2. அவ்வளவுதான் appropriate நீங்க convert பண்ணிக்கணும். So these are all the important conversions that you must know. Okay. Next, moving on to the next formula. அதுக்கப்புறம் we have potential energy of a system of charges. So next we are going to see what is the potential energy of a system of charges. So system of charges இருந்துச்சு அப்படின்னா நம்ம how to calculate it. Potential energy is given by the symbol U. So U is equal to K times. So நம்ம வந்து we are always expressing in terms of interaction of the charges. So ரெண்டு charges or interaction தான் we generally represent.
Q1 into Q2 divided by R.
Correct. So Q1 by Q2, Q1 times Q2 divided by R12, that is between 1 and 2. அதே மாதிரி Q2, Q3 na R23. So அந்த மாதிரி you keep expressing. So it is K times say Q1, Q2 by R12 plus Q2, Q3 times R. இங்கே வந்து 2, 3 plus so on up to Q. Now we generalize it. So you write it as Q n minus 1 times Qn divided by R n minus 1 times n. So like this you can generally go and express. Or you can also appropriately use a summation operator also. So U is equal to use summation. So இங்க வந்து you can express
Summation of
K times இப்போ வந்து sigma
I
போட்டு
is equal to I is equal to 1 to n Qi plus 1 divided by Qi into I plus 1.
ஆமா. So you will write this as Qi times Qi plus 1 upon R I times Ri into I plus 1. So இல்லைனா நீங்க ரெண்டு வேரியபிள் கூட எடுத்து நீங்க ரெப்ரசென்ட் பண்ணிக்கலாம் if it is necessary. So I and J கூட எடுத்து கூட you can express. It is your choice. But this is the general method of expressing the potential energy of a system of charges. Okay. So this is how you do it. And then moving on to the next one. The next formula. Capacitance of a conductor. Formula for capacitance. So capacitance when we represent using C. So C is equal to
Q by V.
Q divided by V. So potential divided by charge divided by potential. So that's the formula. So the standard units பாத்தீங்கன்னா C ஓட unit வந்து is farad and Q வந்து is in coulombs and V is in volts. So we express like this using the appropriate ways. So inge வந்து we have different ways of expressing capacitance. First வந்து 1 millifarad. How would you write 1 millifarad?
5/9.
Yes. 5/9. No, it's not 5/9.
9/5.
No. Milli na 10 power minus 3 இல்லையா 1 upon 1000 தானே. So 1 millifarad is 10 power minus 3 farad. That's it. 1 microfarad வந்து எப்படி எழுதுவோம்? Microna it is 10 power minus 6. Isn't it? Same way, 1 nanofarad. How do you write?
10 power minus 9, sir.
ஆமா 10 power minus 9. Finally, 1 picofarad. How do you express that? The conversion is 10 power
minus 12. 20,
Correct.
sir. 12.
இல்ல 12 தான். 10 power minus 12. So milli, micro, nano and pico. So appropriately you will have to know this. Okay, angstrom வந்து உங்களுக்கு இதுக்கு நடுவுல வரும் nano and pico, so which is 10 power minus 10. அது வந்து உங்களுக்கு ஏற்கனவே தெரிஞ்சது தான். So I'm not again repeating that. So this is the basic formula for capacitance. ஓகேங்களா? Next, capacitance of a spherical conductor. Formula needs to be known. So capacitance of a spherical conductor. So the formula for capacitance of a spherical conductor is given by C is equal to 4 pi epsilon naught into R. இப்போ இதுவே வந்து I want to express in terms of K. அப்படின்னா what will I do?
1/k into R.
So R by K ன்னு எழுதிக்கலாம். Okay? Yes. So these are the two different ways of expressing the capacitance of a spherical conductor. Next formula. Parallel plate capacitor. Capacitance of a parallel plate capacitor is what we are going to see. So parallel plate capacitor கொடுத்தாங்க அப்படின்னா the capacitance is given by C is equal to epsilon naught into A divided by D, where A is the area of the plates and D is the distance of separation of the plates. So this is the formula for parallel plate capacitor. So I will give you the values. So A is the area and D is distance of separation. Okay, so area வந்து எப்பவுமே has to be in meter square and distance of separation has to be in meters. Next one. Next one, if you are having a two concentric spherical capacitors conducting shells, so we are going to see capacitance of two concentric spherical conducting shells of inner and outer radii. Of inner and outer radii A and B. So A வந்து inner radii, B வந்து outer radii. So what is the relation between A and B?
4 pi A minus.
Yeah, B is going to be greater than A. Yeah, that is a bigger radii. அப்படிங்கிறதுனால. Okay, so now we'll go to the formula. Yes, சொல்லுங்க.
4 pi B minus 4 pi A into epsilon naught.
Yes, so it is 4 pi epsilon naught times AB upon B minus A. You just go for a simplification. Simplify it and write it. So you will get 4 pi epsilon naught AB upon B minus A. So this is the general formula that we would use. Okay. So inge again in terms of K வந்து நீங்க incorporate பண்ண விரும்புறீங்க அப்படின்னா directly you can write it in terms of K as K வந்து கீழ வரும். So you can write it as AB upon K times B minus A. This is another version, simplified version of writing the same. So this is capacitance of two conducting concentric spherical shells having inner and outer radii A and B, wherein B is greater than A. So in the relationship, we will use this formula. Okay. Next, cylindrical capacitor. When you have a cylindrical capacitor, so Apo, what is the formula that you would typically use? Okay. So if the capacitor is there in the form of a cylinder, then C is equal to, we express this as 2 pi epsilon naught upon log to the base E B upon A. Okay. Log to the base E B upon A. So we use this formula. So logarithms we are going to use. So what is the formula for log? So log when the A by BO or log B by AO. So how do we
log B
express?
minus A.
ஆமா. So இங்க B and A வந்து confuse ஆகாதீங்க. திரும்பியுமே this is also a inner and outer radius தான். ஓகேங்களா? So inner radius as usual A and outer radius is as usual B. Okay, length நான் போட மறந்துட்டேன். I'll just put the length also. Where L is the length. ஓகேங்களா? So I will write it here. B is outer radius. A is inner radius. And L is length. ஓகேங்களா? So அதை வந்து நீங்க expand பண்ணீங்க அப்படின்னா you will write it as log B minus log A. Correct. So you can express it like that also if you wish. So இப்போ வந்து 2 pi epsilon naught இருக்கு இல்லையா? So you can express that in terms of K also. But we know that K is 1 by 4 pi epsilon naught. So K is always this. But how can you express 2 pi epsilon naught?
1 by K divided by 2.
So you will get 1 upon 2K. Isn't it? So 1 upon K, 2K you will get. In the place of 2 pi epsilon naught, 1 by 2K அப்படின்னு நம்ம எழுதிக்கலாம்.
Sir, 2 by K தான் sir.
2 by K. Okay, எப்படி 2 by K வருது?
Sir, 1 by 4 pi epsilon naught அதுல உள்ள பாதி தானே சார் 1 by
ஆமா
2.
4 pi epsilon naught வந்து நம்ம எப்படி எழுதிக்கலாம்? You can't you write it as 2 into 2 pi epsilon naught? இல்லையா?
Yes, sir.
அந்த 2 pi epsilon naught மட்டும் நீங்க இந்த சைடு ஷிஃப்ட் பண்ணுங்க. K வந்து you again bring it back.
Okay, sir.
Correct தானே? So you get 1 upon 2K தானே?
Yes, sir.
So you can write 2 pi epsilon naught as 1 upon 2K. So finally, you can write this as L divided by 2K into log to the base E B by A. So you can write it like this. This is one more version of writing. எப்பவுமே Kல எழுதுறது வந்து is best because K ஓட வேல்யூ நமக்கு டைரக்டாவே தெரியும் அப்படிங்கிறதுனால you can directly substitute. அந்த பையை வந்து நம்ம simplify பண்ணி நம்ம we not waste the time. That's the reason நம்ம Kல வச்சுக்கிட்டா it is good for us. Ease of calculations. Okay, next. So 11th one we have written cylindrical capacitor. Now moving on to the 12th formula. So capacitance, combination of capacitors we are going to see. So capacitors we have two different combinations. One வந்து series combination and one more is parallel combination. So what is the formula for series combination of capacitors? So you can write that 1 upon C in series is equal to 1 upon C1 plus 1 upon C2. So இப்படி போகும் 1 upon Cn. அப்படின்னு we express. Same way for parallel combination, Cp is equal to just direct addition.
C1 plus C2, C3 plus Cn, sir.
Plus Cn. So these are the formulas for capacitance in series and capacitance in parallel. So parallel order நீங்க reciprocal பண்ணீங்கன்னா you will get the series. So that's how they are interlinked. So this is a combination of capacitors. Next, energy stored in the capacitor. We're going to see so what is the energy stored in the capacitor. So energy stored by capacitor is given by U is equal to half into CV square. திரும்பி நீங்க வந்து C substitute பண்ணலாம் in terms of Q and V, and same way V in terms of C and Q. So அந்த மாதிரி substitute பண்ணி rearrange பண்ணீங்க அப்படின்னா you will get the other formulas as 1 by 2 Q square by C அப்படின்னு also you can express, which is also same as 1 by 2 Q into V. So these are all the possibilities for the formulas of energy stored by a capacitor. The unit is going to be in joules. Okay, so this is a formula for energy stored in the capacitor. The 13th one. Next, 14th formula. Energy density is also there. So energy density, now you need not worry. It is the energy stored per unit volume. That's energy density. I repeat, it is the energy stored per unit volume. So that is what we express energy density. Okay, so we express that in terms of electric field. So the density in a region with electric field can be expressed as small u. So small u is equal to half into epsilon naught into the square of electric field, E square. So this is the formula for energy density. So very important. So epsilon naught is permittivity in free space, and E is nothing but your electric field associated. So that is how we express. Okay, this is the method of expressing it. Fine. So, and then we have dielectric constant. So dielectric constant irundhuchu appadina, how do you express the corresponding values? So capacitance of a capacitor filled with dielectric. So a material, a jelly-like material da adu. So when you fill the capacitor, parallel plate capacitor with a dielectric, having some dielectric constant, ஏன் dielectric use பண்றோம் அப்படின்னு பார்த்தீங்கன்னா to enhance the capacitance, to enhance the conductivities. So we have a dielectric which has been a slab which has been inserted. So அது பார்க்கலாம். So next we are seeing the capacitance of a parallel plate capacitor filled with a dielectric. Filled with a dielectric. So you can write it as C is equal to K times C naught. Okay, where C naught is the capacitance with the dielectric. So we can write this as epsilon naught K times A upon D. So with dielectric on, already nama paatadda. Without dielectric, what was the formula for parallel plate capacitance? It was just epsilon naught A by D. இப்போ dielectric நம்ம introduce பண்றதுனால என்னாச்சு? It became K times the capacitance. அதுதான் relationship. So அந்த ஒரு logic நீங்க understand பண்ணிக்கிட்டீங்கன்னா it's going to be very simple. So by introducing dielectric, what happened to the capacitance? It got enhanced by K times. Yes, அவ்வளவுதான். Next, we are going to see the capacitance of parallel plate capacitor with a dielectric slab between the plates. So filled with the dielectric is different. With just placing a dielectric slab is different. So idu vandu neenga something to be very vigilant. So completely neenga fill pandringa appadina there is obviously there is no gap in between. But when you are inserting a slab and there is a gap, so there is something called as a thickness that comes into picture. So adukku vandu oru separate thickness irukku. You are not completely filling it. There is gap also in between. So appo you will have to consider that thickness alone and you will have to write the formula. So aduvum paathirala. So next one, I'll just give you. So it is a capacitance of a parallel plate capacitor of a parallel plate capacitor with a dielectric slab between its plates. So between its plates irundhuchu appadina, then that also I will give you if say T is the thickness. If T is the thickness of slab and T is less than D. Okay, and T is less than D, where D is, you know, the distance of separation of the plates. Adha na sonnai. And T is less than D. In the rendu conditions nama munnu vechu da we are writing the formula. So in that case, that capacitance C is given by epsilon naught A, the whole divided by D minus T into 1 minus 1 by K. So this is the formula to be used appropriately when you are having a thickness and T is less than D. You have to use this formula to solve the questions. Where K is dielectric, D வந்து என்னது? D is distance of separation between the plates. T is thickness of the dielectric slab introduced between the plates. So appo you will use this formula. Okay, this is the formula that needs to be used in that case. Next one, we are moving on to the next formula. Next one, you have capacitance of a parallel plate capacitor again with a conducting slab between its plates. So I am going to place a conducting slab. When there is a conducting slab, then what happens for T less than D? Parallel plate capacitor with a conducting slab between the plates or between its plates. So inge condition is for T less than D. So the same condition da, it is going to be less than D, then what is going to be the capacitance is what we are analyzing. So C is equal to, so D upon D minus T, the whole brackets, times epsilon naught A divided by D. You can express it like this. Or epsilon naught A by D வந்து C naught தான். So அதனால further இதை போய் D by D minus T times C naught அப்படின்னு கூட எழுதிக்கலாம். சரிங்களா? Where C naught is epsilon naught A by D. That's it. So this is how you can express. Okay. Same way, the next formula. So we are seeing capacitance of a spherical capacitor filled with dielectric. So filled with dielectric. So appo, what is going to be the capacitance? So it is 4 pi. Already nama paathathu vandu 4 pi epsilon naught into. So already we saw what was the formula for the capacitance of a spherical capacitor. I gave you in the beginning.
K
epsilon naught into AB divided by B minus A. Yeah.
Yes, sir.
Yes. Inge vandu it will be K times that. Avladha. Okay.
Okay, sir.
It's going to be K times, where K is your dielectric constant. K times the original case. Okay. That is 4 pi epsilon naught
Hello.
into AB upon B minus A. So this is the formula. Simple. So K C naught also you can express. So this is the formula for capacitance of a spherical capacitor filled with dielectric. And cylindrical capacitor with dielectric. All of that. Next one, 19th one. Capacitance of a cylindrical. Idhukku try pannunga the formula how you can modify it with dielectric. Filled with dielectric. So idhukku vandu the formula eppadi change agum. C is equal to again K times cylindrical capacitor கொடுத்த நான் ஒரு ரிலேஷன்ஷிப் தான் நீங்க இங்க யூஸ் பண்ண போறீங்க. So what would be the formula then? K into 2 pi epsilon naught L divided by log to the base E times B by A or B upon A. Simple. So this is the formula for capacitance of a cylindrical capacitor with dielectric. Okay. That's it. So these are all the formulas. So all the formulas now we have seen. Totally 19. In between also if you are having some other formulas, I will tell you. So this is the basic. All the important formulas we have covered. Okay. So we will start seeing the questions based on this. Yeah, here comes a question. First question on the screen. Okay, a parallel plate capacitor having plate area 100 centimeter square with separation 1 millimeters holds a charge of 0.12 microcoulomb. When connected across a 120 volt battery. Full stop. The dielectric constant of the material filling the gap is options. Option A, 22.3, option B, 11.3, option C, 26.4, option D, 33.4. So இதை ட்ரை பண்ணுங்க. So appropriate எந்த formula நீங்க choose பண்ணலாம் based on the given data is what you will have to think and find out. Yes, anybody got the answer for this?
Sir, 11.3.
11.3, very good. 11.3 is correct. Okay. So what is the method? What formula did you use?
So C is equal to Ka epsilon naught divided by D. Next
Correct.
Q is equal to CV, sir.
ஆமா.
From
ஏன்னா
this,
நமக்கு C கிடையாது. First C கண்டுபிடிக்கணும் இல்லையா? அப்போதானே you
Yes,
can
sir.
find out
C.
the dielectric constant. Yes.
Yes, C கண்டுபிடிச்சு அப்புறம் C ல இந்த C is equal to Ka epsilon naught by D ஆல C ய கண்டுபிடிச்சு Q is equal to CV ல C ய போட்டு
So
கண்டுபிடிச்சு
C ஓட formula C is equal to
Ka epsilon naught divided by D.
correct. If first வந்து capacitance கண்டுபிடிக்கிறதுக்கு normal the capacitance C is equal to Q by V யூஸ் பண்ணீங்களா?
Sir, நான் Ka epsilon naught divided by D யூஸ் பண்ணேன் sir.
K epsilon naught by D you used. Okay. இங்க பாருங்க, first you should use this இல்லையா to find out what is the capacitance. Only then you can use that C is equal to K epsilon naught. ஏன்னா ரெண்டு unknown இருக்குமே டைரக்டா அது யூஸ் பண்ணீங்கன்னா. So first you should find out capacitance, which is
Okay, sir.
so 12.12 microcoulomb வந்து நம்ம 12 into 10 to the power micro வந்து 10 power minus 6. So அந்த 0.12 வந்து நம்ம எப்படி எழுதிக்கலாம்? 12 into 10 power minus 2 ன்னு எழுதிக்கலாம். So
Yes,
minus
sir.
6 minus 2 வந்து is minus 9. So I'm directly writing divided by voltage. Voltage வந்து 120. Isn't it? 120 volts.
Yes, sir.
So what happens?
சரி, இந்த ஃபார்முலாவை நான் செகண்ட் போட்டு இந்த ஃபர்ஸ்ட் வந்து C is equal to Ka epsilon naught divided by D ல கண்டுபிடிச்சு Q is equal to CV ல சப்ஸ்டிட் பண்ணிட்டேன் சார் C ய.
Okay, அப்படி கூட பண்ணலாம்.
Okay,
That
sir.
is also fine. So you will get it as 10 power minus 9 farad. So once you have found out C as 10 power minus 9 farad, so இங்க வந்து you would get minus 6 and minus
10 power minus 10 தானே சார் வரும்?
10 power minus 10 வரும் இல்லையா?
Yes, sir.
Let me check. Yeah. Okay. So you get 10 power minus 9 farad as C. So when C value is 10 power minus 9 farad, அதுக்கப்புறம் நீங்க சொன்ன மெத்தட் தான். So K into epsilon naught A by D. So use this. So you go and substitute. K க்கு வந்து rearrange பண்ணீங்க அப்படின்னா you will get it as CD by epsilon naught into A, which is 10 power minus 9
சார் 10 பவர் அந்த இடத்துல 10 பவர் மைனஸ் 8 வரும் சார். 12 into 10 பவர் மைனஸ் 8 divided by 120.
12 into 10 power minus 8 divided by
120 சார்.
but இங்க வந்து we are rearranging no
10 பவர் மைனஸ் 6 அதுல வந்து 2 டெசிமல்ஸ் வந்து நம்ம கூட்ட முடிச்சிட்டு 10 பவர் மைனஸ் 8 தான் சார் வரும்.
10 power minus 9 தானே வருது சிம்பிளிஃபை பண்ணுவோம் அப்படின்னா. ஏன்னா கீழே இருக்க 0 வந்து மேல கொண்டு போறோம் இல்லையா?
மேல கொண்டு போனா 10 பவர் மைனஸ் 1 தானே சார் வரும்.
1 second
10 பவர் 11 ஆயிருங்களா சார்?
1 second let me check it.
ஓகே சார். இது 10 பவர் மைனஸ் 8 வரும் சார்.
Okay,
12 into 10
Q-
பவர் மைனஸ்
12 into 10 power minus 8. Okay, so 0.12 into 10 power minus 6. Is this correct for charge?
எஸ் சார். எஸ் சார்.
Yeah. இப்போ 0.12 வந்து let's go for a conversion. That is 12 into 10 power minus 2.
மைனஸ் 18 மைனஸ் 8 சார்.
இல்ல 0.12 மட்டும் சொல்லுங்க. That is 12 into 10 power minus 2 தானே. அந்த by 100 வந்து நான் மேல கொண்டு வந்துட்டேன்.
எஸ் சார். எஸ் சார்.
Okay. Into 10 power minus 6 ஏற்கனவே இருக்கு அந்த மைக்ரோட வேல்யூ which is 12 into 10. So 12 is getting cancelled. That 10 is going up becoming minus 3 தானே.
எஸ் சார்.
minus 3 minus 6 minus 9 தானே வரும். That is what I am telling.
எஸ் சார். லாஸ்ட் ஆன்சர் வந்து 10 பவர் மைனஸ் 9 வந்து சார். நீங்க ஃபர்ஸ்ட் 0.12 into 10 பவர் 12 into 10 பவர் மைனஸ் 10 போட்டிருந்தீங்களா சார்? அதுல மைனஸ் 8 வரும் சார்.
Acha, okay. But finally you will get minus 9.
Yes,
Okay.
sir.
Yes. So minus 9 varum. Ipo, now you go and substitute this here. 10 power minus 9 into distance of separation. How much they have given? 1 millimeter, which is 10 power minus 3 divided by epsilon naught வந்து 8.85 into 10 power minus 12. Into
Yes, sir.
area. What is the area of the plates?
10 into minus 2 sir.
100 centimeter square. அதை வந்து மீட்டர் ஸ்கொயர்ல கன்வெர்ட் பண்ணோம்.
10 into minus
Okay. 10 square into 10 power minus 4. Or 10 power minus 4 into 10 square is 10 power minus 2. Okay. So இதெல்லாம் நீங்க simplify பண்ணணும். So you go for a simplification.
மணிஷ் ஒரு 5 மினிட்ஸ்ல
So minus 12 minus 2 is minus 14. Minus 14 going up plus 14 plus 14 minus 9 minus 3.
மணிஷ் ஒரு 5 மினிட்ஸ்ல க்ளோஸ் பண்ணிடலாமா?
Yes uncle.
எனக்கு
We'll wind up.
குழந்தைகள்லாம் பசிச்சிரும். 9:15 ஆச்சுல.
Okay. Yes uncle. Yes uncle. So plus 14 and minus 12. So which is plus 2. 8.85. So 10 power 4 divided by 885. So இது simplify பண்ணீங்கன்னா you're getting 11.3.
11.3.
Correct. So that is the value. சரிங்களா? So 11.3 வந்து pertains to option B. So option B is correct. So in the மாதிரி you will have to step by step solve it and get. So first formula based on the given data. So இங்க பாத்தீங்கன்னா ரெண்டு unknowns இருந்துச்சு. So we have to find out the first unknown and then substitute to finally arrive at the answer. So அந்த ஒரு approach தான். So first capacitance கண்டுபிடிங்க. Then you go for a substitution and then find out what is the value of dielectric slab that needs to be used, or I mean the filling of the dielectric material that needs to be used. Avalada. So that is how you approach this type of question. Okay, so I will post this notes also today. So we'll wind up. I do understand that you are hungry. So even I am also hungry. Okay, so anyways, so again.
Children are hungry and it includes you also.
Yeah.
நீ child தானே.
Yeah, of course. Okay.
Okay, thank you.